Yes, welcome back to Torsion Engineering Academy. It is still your lecture series that is ongoing on the topic Torsion. Please don't forget to subscribe to this channel, Torsion Engineering Academy. So let's continue to our problem. This is our problem number 5. Okay, so don't forget that we are still handling this. Now the question says a 10 meter hollow shaft, meaning length is equals to 10 meter, of internal diameter 20% of the external diameter, meaning that let's say this is what internal diameter is equals to 20% is 0.2 of the external diameter. If my external diameter is capital D, it transmits a power of 600 kilowatts, so P is equals to 600 kilowatts, which is 600 times 10 raised to the power 3 watts. At number of revolution there is 150 revolution per minute. Determine the external diameter, that is capital D, if the shear stress, that is tau, is equals to 35 Newton per millimeter square, right? And the angle of twist, theta, is not to exceed 1.5 degrees, right? You and I know very well that now this is supposed to be converted to radian, so I multiply this by pi out of 180. You're supposed to take T maximum to be equal to 1.2 T minimum and take G to be what? This, right? This is the information provided. Now since my eye is not seeing the value of T, I have to first calculate it. T, okay. But from the expression that last time I had given, that power is equals to omega T and power is equals to 2n pi out of 60 times T. This expression will help me to get the value of what? T. So let me do it here. What is power? Power is 600 times 10 raised to the power 3 watts equals to 2 times n is 150, and times pi. Divide this thing by 60 and multiply this by T. So if you bring all this on this side, you'll get the value of what? Of T. You have to confirm this from your calculator. I am getting 38.2, I mean, not 28, 38.2 times 10 raised to the power 3. The unit is in what? Newton meter. Check that. And this value of T is equivalent to what we call T minimum. Okay, or T min. But our expression for T maximum is given that it's 1.2 of that. So 1.2 times 38.2 times 10 raised to the power 3. So the answer is coming to 45.8 times 10 raised to the power 3 Newton per meter. This is the value of T what? T maximum. And using this value, we can now proceed to get the value of what? Of D. Okay, because the question wants us to get D. So from this expression of T maximum, divide by the J equals to tau, divide by radius, where radius is D by 2. So since this is hollow shaft, I have told you in the previous video that you have to consider the expressions because there are two diameters. So our T is 30, not 38 now, we are using T maximum, so it's supposed to be 45.8 times 10 raised to the power 3. Divide this by what? J. J is pi by 2. And then multiply by what? R to the power 4, but R is the same as D divided by 2. Raise this to the power 4. Okay. This is equivalent to, now I've told you that this is hollow shaft, But this expression was for solid shaft. So for me to make it hollow shaft, I'm supposed to have what? D to the power 4 minus small d out of 2. This also raised to the power 4. Okay. This is the correction you need to have there. Because it is hollow shaft. Everything is equated to tau, where our tau is 35. Okay. So this unit is already in Newton per millimeter square, and my answer, I will get it in millimeters, so no need to convert anything there. So divide by R is D by what? D by 2, and this D is capital D. Alright, so you need to make substitution for this small d. Just allow me erase this part, so that we can only think we have captured. Okay. So this is going to be 45.8 times 10 raised to the power 3. Then divide by, this is 2 to the power 4, that is 16. Pull that 16 out, 16 times 2 is 32. So this is 5 out of 32. Then d to the power 4 remains here, minus small d. Okay, small d, but remember, small d is 20% of capital D, which is 0.2 capital D. Raise this to the power 4. Okay, so this part is simplified. This equals to 35. Divide this by D by 2. From this, there is only one variable now, only capital D. So hence, if I simplify this, it is going to come so easily. Okay, if you want to further simplify, so this is 45.8 times 10 raised to the power 3. Multiply this by 32, because the 32 is in the denominator, can go up. Divide this by pi, this pi. Okay, then I can pull out the capital D out. Capital D to the power of 4. What I remain here is 1 minus 0.2. Remember, this is also to the power 4. Okay, is equals to 35 out of d by 2. I can also take this 2 up, by the way. So multiply this by what? By 2. Okay, so d to the power 1 and d to the power 4 will reduce this power to power 3. So I can take this d to the power 3 this side. I'll have 45.8 times 10 raised to power 3 times 32. Divide this by pi times 0.8 raised to power 4, which is this part. Then multiply by this 35 times 2 is equals to, take this to the power 3 this side, then get cube root on this side. Okay, get this 1 by 3. So our final answer for the value of this is coming to 319 in millimeter. Okay, please do press that, confirm whether you can come to this answer. But this is considering what? The first part of the expression of torsional equation, which is what? T by J is equals to tau by R. What if I consider T by J is equals to G theta by L? If I consider this part, can I get the same answer? Because we know G. So I can also take this part. So let's do that, because you have two sides. You do the first, then you do the second, then you take which one is giving you a bigger value. That will be your final one answer. So for this part, it's done. Let's go to the second part. Second part of this question. So you should take note of the value of D we have got first. So let's take the first case, the second case, I mean, is equals to G theta by L. Okay, so what is our T? T is 45.8 times 10 raised to power 3 out of pi by 32 now. Okay, we're just simplifying J. So D to the power 4 minus 0.2D, raise this to the power 4 also. Okay, yes. Everything is supposed to be equated to G our G is given 8 times 10 raised to power 4 times theta. Theta is given to be 1.5 degrees, which is 1.5 pi by 180. Okay? And divide by L. L is given to be what? 1, 0. That is 10 meters. 10 meters in millimeter is 10th. Alright. So this is the expression you have. If you simplify just the same way we simplified the other one, you're going to get the value of what? D. Please do simplify this. Pull out this D. Okay, this 32. 45.8 times 10 raised to power 3. Multiply this by 32. It will go up. Divide this by 5. Okay. Then you're supposed to multiply this by what will remain here is 1 minus 0.2. Raise this to power 4 also. Okay. D to power 4 is out. Then if I bring the whole of this in the denominator here, okay, bring the whole of this here, it's 8 times 10 raised to power 4 times 1.5 pi out of 180. That is what we have in the numerator. This denominator, I can bring it up here. So that means this is times what? Times 10th. Okay, times 10th. Then I take D to the power 4 this side. So get this fourth root here. And also do the same what? Here, 1 by 4. So you come out with the value of what? D. And according to my calculator, I'm getting 271 in millimeter. Remember the first value was 319. The other first D was 319 millimeter. So the maximum between the two is our final answer. Therefore, D will be equals to 319 millimeter. This marks the end of this part of this question, and for today we're stopping here. Thank you so much for attending. So please, those who are watching, don't forget to like, share, comment and subscribe. Watch the previous video to understand what all these other videos, because you started with the concept and the problems are being solved. Yet we still have some more videos on this topic, then we wind it up. Thank you so much.